Right, we're in lesson 10 on custom factors. When we first look at factors, we explore the set of built-in factors. Frequently, a desired computation isn't necessarily included as a built-in factors. In those cases, you will need to define your own. One of the most powerful feature of the pipeline API is that it allows us to define our own custom factors. When a desired computation doesn't exist as a built-in factor, we define our own. So conceptually, a custom factor is identical to a built-in factors. It accepts inputs, window length, mask as a constructor arguments, and return a factor object each day. So let's take an example of computation that doesn't exist as a built-in factor, so standard deviation. So let's get the notebook. Okay, so we're gonna follow through with this. So to create a factor that computes the standard deviation over a trailing window, we can subclass the quantopian.pipeline.customFactor and implement a compute method whose signature is of this. So you have self, which is a class, Python class, today, assets, IDs, out, and also asterisk inputs. So inputs are m times n numpy array, where m is the window length and n is the number of security, usually around 8,000 unless a mask is provided. Inputs are trailing data windows. Note that there will be a 1 m times n array for each bound column provided in the factors input list. The data type of each array will be the d type of the corresponding column. Out is an empty array of length n. Out will be the output of our custom factor each day. The job of compute is to write output values into out. Asset IDs will be an integer array of length n containing security IDs corresponding to the column in our star or asterisk inputs array. So this is really the asset IDs. And today will be pandas timestamp representing the day for which compute is being called. So of these, asterisk inputs and out are the most commonly used. An instance of custom factors that's been added to pipeline will have its compute method called each day or every day. For example, let's define a custom factor that computes the standard deviation of the close price over the last 5 days. To start with, let's add custom factor and numpy to our import statement. So let's just import this and run this. So we need to, from quantopian.pipeline, we import the custom factor, and we also need to import numpy. So let's define our custom factor to calculate the standard deviation of a trailing window using the numpy NaN standard deviation. So we define a class called std, standard deviation, bracket, custom factor. And within it, we define compute, self, today, asset ID, out, and value. So exactly a replication of what was actually being stated over here. Okay, so we're going to calculate the column-wise. Column-wise, remember, is down. Standard deviation ignoring the not a numbers. So everything in terms of the output will be stored onto out. We're using numpy and NaN std and values, which is this one here, m times n, and exist is equal to 0. Finally, let's instantiate our factor in make pipeline. So std or standard deviation is equal to std dv, which is what we define here. The inputs is what are we computing against, which is the close price, and window length is 5. Okay, so here we define the standard deviation class. Here we actually specify what we want to compute on. So we compute on the close price as well as how long, 5 days in this case, and everything to be stored in the pipeline column called std_dev, and this refers to that variable. So when this pipeline is run, the standard deviation will compute. .compute will be called every day with data and the following manner. Because we didn't have mask, so in this case it will run the standard deviation calculations for all 8,000 stocks, and is a m times n numpy array. N is all the assets that's in the Quantopian database. M in this case is 5 because we specify 5 window length, and it will basically, that's what the values will be being fed. So that's what this value is. Out an empty array of length n, because we are only calculating a standard deviation over 5 days, so it will only be one single, in this case, one single array of length of n. In this case, the job of compute is to populate out with an array storing 5 days close price standard deviation. Okay, so I think I've run this, but let's run that anyway, just in case. So run the pipeline for 2015 May 5th. So as you run this, you can see that we have all 8,000 something columns, and we have the 5 days standard deviation for the whole stocks universe. The default inputs. When writing a custom factor, we can set default inputs and window length in our custom factor subclass. Which part is that? Let's come back up here. So the subclass is this one here, so we can actually put in the default for ahead of time. So we have the inputs and we also have the window length ahead of time. You can put that as a default upfront in this subclass here. So here we are defining a subclass called 10-day mean difference, brackets custom factor, the inputs being close price as well as the opening price. And the window's length here is 10 days. We are interested in the 10 days, the last 10 days, trading 10 days. Again, we have this self today asset IDs out close, but there's a slight difference. There's an open here. So let's compare this to what we have earlier. So we have self today asset ID out and values. Here, instead of values, we have two that we define here, the close as well as the open. So under out, we just basically calculate the mean between close and open for the last with the axis of 0. So remember, in this case, that close and open are each 10 times roughly 8,000 is a 2D numpy array. Okay, so if we call 10-day mean difference without providing any arguments, it will use the defaults, which is what's stated here. So we will compute the 10-day mean difference between daily open and close price. So the close open diff is equal, this is the variable which we store the output of this. So just let's run that. The defaults can be manually overridden by specifying arguments in the constructor cell. So high-low difference is slightly different from that, but this time round we want to look at high and low rather than the open and close price. Well, we'll run that. Some further example, let's take another example where we build a momentum custom factor and use it to create a filter. We will then use that filter as a screen for our pipeline. So let's start by defining a momentum factor to be the division of the most recent close price by the close price from n days ago, where n is the window length. Here we have the subclass momentum within custom factors. The inputs default is the close price, and we define the momentum being close -1 and close 0. Again, it's the self today assets out and close as well. So let's take the example of 10-day momentum factor. -1 here refers to the latest, whereby close 0 here refers to the oldest. So 10 days ago close price to calculate our momentum factor. So we're going to do 3 things here. Calculate the 10-day momentum factor, 20-day momentum factor, and also a positive momentum filter. So here we have 10-day momentum factor using the momentum subclass that we define here. The window length here is 10, and the 20-day is has a window length of 20. Positive momentum really is combining the 10-day does it equal to 1 or greater than 1, and the 20-day is it greater than 1 as well. So if today's price, which is the latest one, divided by price 10 days ago for the 10-day momentum is greater than 1, then we have the price have gone up, right? So if the price today is 10, the price 10 days ago is 8, then we've gone up 1.25. Whereas if you're looking at the 20, is exactly the same principle. Greater than 1 means that our price have gone up. So let's add this to the pipeline and see what it looks like. So we have these two, which is the same as what was defined. This is the positive momentum future. We also want to include the standard deviation of the close price for the last 5 days. We store this as a column to be returned with the pipeline, but this time around we want to screen for positive momentum only. Now, there might be some confusion between screen and mask. Mask actually forces pipeline to only perform computations on the subsets, okay, a smaller subsets. And whereby screen, computation is still done on all 8,200 plus assets. But screen will only return the smaller subset. So the difference between mask and screen is such that screen is computationally more expensive. Every computation is done on everything, but you get a smaller subset and the output. Whereby mask actually forces the computation to be on a smaller subset along the way. Right, when you run this pipeline, and over this period, I think I didn't run this momentum and run this and run this. And as I run this, and you will see that the standard deviation, the 10-day momentum and the 20-day momentum are all stored here. And that's really how you actually make use of the custom factor, and you can actually define your own custom factor for computation in pipeline. They are frequently the best way to perform computation on a partner data sets or on multiple data columns, and you can actually see the full documentation using this as well. So in the next lesson, we will look at the combining everything all together, and I look forward to seeing you then.